Alright, chapter 7 continues with last chapter on quadratic functions. Now we're going to look at quadratic equations. And in section 7.1, we're going to solve quadratic equations by graphing. So this is our goal. And we'll work through a previous example that we had ended chapter 6 with. In the example, a missile is fired from ground level, and it's modeled by the quadratic function here, where ht represents the height in meters, and t represents time in seconds. And what we're asked, first question, indicate the position along the path trajectory above where the rocket gains a height of 0. Well, rocket would have a height of 0 at the beginning and here. So those are the positions that we're asked to find. So here, or right there, height is 0 just when it begins, and the rocket has a height of 0 when it hits water. Now, for the function, which variables to replace by height of 0 for these positions? Well, we're going to replace ht, where h is a function of t, height is a function of time. This is going to become 0. What you will be left with is finding the time when that happens. So if we rewrote it, so the rest of the question is going to focus now on how do we find the time, what is the time, and how do we find it when the height is 0. So just the difference between quadratic equation and a function now, because last chapters were all on functions. It's a second degree polynomial equation. In other words, the highest exponent is 2, and we spoke about the degree in the last section. And standard form quadratic equation, here it doesn't say equal, it's equals to always a number. So it's not equal to a variable, it's equal to a number. Now use the graphing software on the Desmos website to determine times when it reaches a height of 0. So negative 20t squared plus 120t. So we go to the site. And we type in the equation. Negative 20. Now, the program doesn't have a t, so I'll put x in. Squared plus 120x. And we need to zoom out on this one. Alright, so we shift it over here so you can see it. So our rocket takes off, obtains a maximum height of 180 meters in 3 seconds, and it hits the ground here, or the water, back at 6 seconds. So there. So it's a height at 0, and at 0 seconds the height is 0, and at 6 seconds the height is 0. So when the time is 0, and when the time is 6 seconds, so at 0 seconds and 6 seconds. Some points you need to remember. Zeros are when the quadratic function touches the x-axis. So the zeros of a quadratic function represent the positions where the height is 0, and the zeros of a quadratic function are also referred to as the roots or the x-intercepts. So over here, solutions to the quadratic equation are 0 seconds and 6 seconds. Oh, sorry, they want the roots and the times are here, 0 seconds and 6 seconds. So now use the graph below to determine the times when the rocket attains a height of 160. So the question is slightly changed. The height of 160 is here. And if we look across, they're asking when does the graph have a height of 160? Well, it has it twice. As the rocket is traveling up, it reaches maximum height on the way, gets a height of 160, and then on the way back down, it gets a height of 160 as well. So that happens if you follow down at 2 seconds, and here if you look down at 4 seconds. And use quadratic function to write the quadratic equation represents a height at 160. When we said at the beginning, this here will be your height. So height is 160. And I could leave it this way, but what I will do is move the 160 over. So it's 0 here, and negative 20t squared plus 120t minus 160. And don't forget you have your A, B, and C values. Negative 20, 120, and negative 160. So how can we algebraically obtain the times to solve the quadratic equation? Well, what we're going to do, we're going to learn how to factor. So factoring will come into play here, and what we just learned here is also graphing.